Hi and welcome to my channel. In today's video we are getting into one important and misunderstood part of any checkpoint firewall, which is interface topology settings. So here we have under network management, we see our interfaces. If we double click any interface, let's get this here, you see here the topology, and if we click modify we have many options here. So you can have perfect policies, perfect routes, and perfect NAT. But if your topology is wrong, nothing will behave the way you expect. Clients can't reach the internet, anti-spoofing fails or blocks all traffic, VPN tunnels break, and troubleshooting becomes a nightmare. In this video, I'll walk you through what topology actually means in checkpoint, how the firewall sees your network, how anti-spoofing decides what to block, and how to choose the right settings for each interface. We will also look at common real-world mistakes and how to fix them fast. So if you've ever stared at an interface and wondered, should this be internal, external, DMZ, or what? So this video will make everything crystal clear. So let's jump in. So for each interface on a checkpoint security gateway, as we have here, you define whether it leads the interface, it leads to the internet, external, like this here. So like, for example, like this interface. So let's take a look at this interface. Let's grab this. I don't know why. So this interface leads to the internet, external, or leads to internal, as so internal or LAN, as this one do here. This is an internal interface. So this helps the firewall understand what kind of traffic to expect on the interface and enforces anti-spoofing rules accordingly. So anti-spoofing checks whether the source IP of an incoming packet matches the expected network behind the interface. So anti-spoofing here, this is very important, and anti-spoofing is the first thing a checkpoint firewall checks when traffic comes in. So if a packet arrives on an interface, but its source IP is not part of the topology defined for that interface, it can be blocked. And here we can see the settings of anti-spoofing. We have detect and we have prevent. Detect will only monitor traffic. So it will monitor traffic if it is anti-spoofed IP addresses or not. It will not drop anything. But prevent will drop spoofed IPs. So detect generates logs for monitoring. It does not do any act. So the topology for each interface is the basis for defining which source IP ranges are valid for that interface in anti-spoofing configuration. So an interface can be defined as being external, leading to the internet, or internal, leading to the LAN. The type of network that the interface leads to, internet, external, all this network internal. So here, this is the default setting. So here, if we choose this one, this is default. And this, it is automatically calculated from the topology of the gateway. So, and we have this override here. So overrides the default settings. So so if you don't want automatic calculations, and if you override the default settings, you still have the external choice here. As we can see, we still can choose internet, external, and internal network. So for this network internal, we have 3 or 4 different options. So the first one is not defined. When we choose not defined, all IP addresses behind this interface are considered a part of the internal network that connects to this interface. But I don't know when to use this option, because if you use it, policy installation will fail. So this one here, I don't really know where to use it and when. Because let's try to make it undefined. And then we cannot install the policy. Let's try to install the policy once here. Install. And this will fail because of that. So I don't really know. So if anyone knows, please comment. As you can see, topology information must be configured in order to, so undefined will fail policy installation. Okay, let's get back there. So network defined by interface, the next option here. Okay, the next option is network defined by the interface IP and net mask. This will allow only the network that directly connects to this internal interface. The next option is network defined by routes. So network defined by routes, the gateway automatically calculates the topology behind this interface. If the network changes, and this is very important here. So if the network changes, there is no need to click get interfaces. So if we add, say we have a router behind our gateway, and we add some SVIs or VLAN interfaces. So you don't need, let's take, okay, you don't need to come here and click this button here. It will update automatically. So this is very, and we will do some lab in defined by routers. So let's continue a bit here. So specific. So a specific network object. You can allow a specific network object here. For example, a network group. We can build a network group here and add it here. And these IP addresses on that group will be allowed by anti-spoofing. And you can see not defined, anti-spoofing is not here, it's grayed out. So a specific network object, as we said, a network host, an address range, or a network group behind this internal interface. And here, lastly, we have interface leads to DMZ. The DMZ that directly connects to this internal interface. So let's talk about network defined by routes, or dynamically updating the topology. So the range of IP addresses behind an internal interface is automatically calculated every 1 second by default. And if you need to change that, so we can click cancel here. Say that we need to change that 1 second policy. We mark an interface and actions and then settings. And we get this error. I don't know why for now, but here you can change that default option, the 1 second option. So let's get back there. And here. So, as we said, 1 second, which is the default value. And that without the need for the administrator to click, as we have seen, get interfaces and install the policy. So here in my lab, I have this gateway and I have this router. We have this client. So let's create a new interface, a new internal or VLAN interface. So now let's create a new VLAN on this switch, on layer 3 switch, to test the network defined by routes, which is best choice when you want the security gateway to dynamically determine the network topology based on the routing table. So when the network defined by routes option is selected, along with perform anti-spoofing based on interface topology, you get dynamic anti-spoofing, which is very important here. The valid IP addresses range is automatically calculated without the administrator having to do click get interfaces or install a policy. Okay, so let's open this switch here, or layer 3 switch. And we need to create a new SVI. So let's take a look what VLANs do we have. Do show brief. Okay, we have, let's create a new VLAN. So VLAN 40, for example. Name I don't know, test, for example. Okay, exit and interface. Let's create interface here. VLAN 40. Give it an IP address so that we can make that interface the default gateway for this client here. So IP address, let's get what we have, like something like 68.21, for example, and no shot here. So let's take a look at it. And now we have VLAN 40 with this IP. Okay, so let's save here. And we need, so this, we need to create the same VLAN on this switch and designate this interface to that VLAN. Let's get that one. Okay, VLAN 40. Name test. Okay, exit. And now interface 0x0 switchboard access VLAN 40. Okay, now we are ready here. So now we need to open our client device here and see. Okay, so let's change the IP address of this client. And we need to give an IP address in the same subnet. So 68 20. Don't really remember. 20 10, and this can be. And we will have the gateway as our gateway here. This switch. Click OK, OK, and close. And let's ping our IP config here. Okay, so ping the gateway. Ping. 20 and 1, and we see we have a ping, so we have connectivity. Okay, so what we need to do now to make anti-spoofing work correctly, so let's run a ping here. Ping for example, this ping 9, for example. Not that one, that one. Something like this. And let's grab again here and check the logs. So here, let's define that by routes now. So this interface is internal and by routes. And let's activate anti-spoofing. And click OK, OK. Okay. and install policy. Let's install that. And at the same time, we can check logs here. There. Okay, we can see the first packet. Okay, we need two things. We need to allow this in rules, this IP range. Okay, and we need to do some netting. So first, let's create that network. I just want to make it very this test like production networks. So let's create, let's say that this network is this one. Let's do some netting here. Yes. Let's add that network here, so it is allowed by policy. Install policy again. I just want to show you how this define by routes is working. And this is the best example because you need to have a router behind your gateway to see this in action. So we have created a new network that does not have anything with the gateway. So we have a new network and a new interface on the router behind our gateway. And when we have defined by routes, directly when the gateway gets a static route that, let's see here. Location, okay, that is not it now. So let's to logs again. See this drop. Okay, as we can see here, address spoofing. So why it is not working? And that is because we don't have a static route on our gateway. So let's get back there. So traffic starts here and gets out. But as we explained in a previous video, when the traffic from the internet comes back to the this gateway, it says destination. Now, okay, let's type that. 10, I think, something like. Okay, let's remove this. Put this here. So when the traffic comes back from the internet to the gateway, it has destination 192.68.2010. The gateway looks at its interfaces. There is no this kind of IP, and it looks on its routes, static routes. So let's open here and see what we have. So show static, no, show route static, something like this, and it looks then on its static routes. So this route is the internet external. This route is not 192, and this route is not 192. So then it does not know. So it sends the traffic back to the internet and it vanishes there. So to fix this, so now back here we see that address spoofing. So the gateway thinks that this traffic should be blocked because it's spoofed. So let's add a static route here. So show configuration. static route. So we need to add something like this, new one. Let's change the IP here only, 22, 68, and 20. And the next hub address is the same, which is this interface here, or it is an SVI. So these can talk to each other. And we click OK here, and let's go back to and wait a second. So we have a ping here. Let's see. So let's check our route here. Okay, as you can see here, that was not very correct. So let's add one there. And let's continue monitoring this. So as you can see, directly when you add a route, everything is green. And we don't need to click anything here. So it just works when you add the route. So you don't need to click anything here, get interface, or install any policy. It just works. So again, here, the 2010 is green. So this is, let's see, okay, this is not something that, as you can see, this is my lab. But as you can see, in general, it is accept. See here, everything is green, so no address spoofing problem. And we can double check again here. That is defined by routes, and that is our anti-spoofing is prevent. It will drop any spoofed IP, which is not defined by routes. By routes, we mean these routes. So the gateway, any interface you add to your router, the gateway should be able to reach it. If it can reach it, so no problem. Anti-spoofing will not block. But if the gateway cannot reach that interface or that IP on the router, it will drop the anti-spoofing. And the same is correct for specific. Here we can create, to use this option, you can create a network group, add all your networks, and then add that group here. And then any in a group or any network here will not be affected by anti-spoofing. But especially when you have a router behind the gateway, use this network defined by routes. It is more automatic to create VLAN interfaces. So I hope this video was useful. So here, someone asked me about that on my on previous video, and I have gave the wrong answer, to be honest. So I need to change this answer to be correct. So this video is done here. So thank you for watching, and see you in the next video.